Welcome and thanks everyone for joining our 2021 webinar series to assist you understand electrical safety and mitigate all risk associated with it. Why do we do this? Education. We don't die from what we know, we die from what we don't know. I just recently, only this morning, Googled this and I found out it's not a quote. So in that manner, I'll claim it as my quote. So it's quite unusual. It hasn't been taken already. So today's topic is very interesting and it deals with infrared thermography value, the pitfalls, and training guidance. For this, we have a special insight from Australia's Ambassador to Infrared Thermology, Jeff Erichsen from Advanced Infrared Resources Australia. Infrared's always intrigued me, and I probably know just about enough to be dangerous. The advantages of this technology over the years has been amazing, and I feel it's one of the most misunderstood and underutilized processes in the electrical safety industry. It's my hope that this webinar arms you with more information to protect your company, your assets, your workers, and the public in general by being proactive in electrical safety. Can I get you to do one thing before we get started here? Just type into the chat of where you're located now. Sandra will review these. It's always very interesting to see where everyone's viewing from. And I believe currently at the moment we have viewers in Switzerland and India as well. So welcome to those viewers in those countries and all across Australia and New Zealand as well. So my name is Kurt Alexander. I'm the founder and CEO of Quick Safety. And I've been around the electrical industry for over 40 years now, with 32 of those years based here in Australia. And it pains me to see that people just accept that all is good and there are no safety checks for the electrician's work. And this is what drove me to develop an easy to use system that removes risk from everyone, from the electricians, the electrical contractors, the asset owners, and that includes residential all the way to oil and gas infrastructure, the directors, and the insurance companies. And it's one of the reasons why we're working closely with Jeff and the team at AIR to ensure all your assets are safe and fully compliant. Okay, let's get on with it. After the introduction of Jeff, who will be presenting, we will dive straight into the presentation. We have Sandra from Quick Safety as our moderator, and she'll be assisting everyone through the chat function. So please ask questions. We'll have time at the end of the presentation to answer those questions. And make sure that you select when you're doing this, all panelists and attendees, or you can ask them through the Q&A selection at the bottom of the screen as well. So we'll have ample time at the end to answer the questions. And even if we have to run over time, we will answer all those questions online. So make sure and ask away. The presentation will be available after the webinar as well. So feel free to tag, share, and comment the presentation. And at the end, we'll give a link to a quiz to see if your building is compliant and a sneak peek into our next asset management topic. So make sure and stay listening for the end and the announcement of that. Now, it's my pleasure to introduce a great guy who has a ton of knowledge in thermography, Jeff Erichsen.
Thank you very much, Jeff.
Yeah, everybody meet Jeff Erichsen. With over 20 years experience as a certified Cat 3 thermographer, a certified Cat 2 electrical thermographer with the Australian Institute of Non-Destructive Testing, and the owner of Advanced Infrared Resources Australia. Welcome, Jeff. Can you tell us a bit more about what you do and exactly why you do it?
Hi, Kurt. Thank you so much for having me. I really appreciate it. I might make one correction there, actually. I've been 20 to 30 years in industry and 8 years in thermography. So don't ever like to purport to be anything that I'm not. But yeah, I got involved in the infrared industry back in 2013. I was introduced to it in 2012, and I saw that there was so much risk to be averted by using this technology. As a heavy equipment fitter in the mining industry for 30 years, doesn't matter whether it's electrical, mechanical, or process, you know, there were so many areas, obviously, that when there's an energy conversion and that energy conversion is a problem, the byproduct is heat. And so when I was introduced to thermography, I found that it just made total sense to me.
Yeah, exactly. Yeah, no, we're super privileged to have you today. So thank you very much. And, you know, I can already tell this is going to be, I've looked forward to this for, I don't know, it's been in the pipeline now for probably a couple of months, but I've looked forward to it more and more each day as the days pass, just because I think it's just going to be an absolute amazing webinar. We actually have some engineering groups who've decided to do their CPD credits through the actual course. So we've got engineering companies in Toowoomba that I know about that are sitting there with their group of electrical engineers that are actually going to hang on every word. So so I'll hand it over to you, Jeff. Go ahead and have your presentation, and we'll meet you at the end.
No problem, Scott. Thanks very much, and I hope I can live up to the hype, that's for sure. I am very passionate about this method of condition monitoring, and I love it. And I'm certainly not the world's expert in it, but I feel very comfortable and also very privileged to be able to present this to people, and it's something that I really enjoyed. So as you can see here on the screen, yes, I'm a Category 3 trained thermographer and a Category 2 certified thermographer. There is a difference, and we'll go through that a little bit at the end. And I've had a lot to do with ultrasound, and I also employ some vibration analysts. So I guess I have a fairly well-rounded understanding of condition monitoring, but in particular, thermography has been my specialty. So I'll tell you a little bit about that now. Bit of a disclaimer, because it's funny how everyone thinks they know a lot about temperature and heat, when in fact they don't, and it's no fault of their own. So I always like to say, this is my disclaimer: infrared thermography is a discipline that's based on science. You know, it's not Jeff Erichsen made it up yesterday, and neither did the rest of the infrared thermography fraternity. So thermal energy and the laws of thermodynamics, they're well proven. They've been around for more than 100 years, and they were developed and proven by people who are a lot smarter than I am. Right? And one of the first things we like to talk about is a law that's undeniable, and that is that energy can't be created or destroyed, only changed from one form to another. And that's the first law of thermodynamics. So in thermography, when we can see the surface of that object where the energy is being changed from one form to another, for example, electrical energy converted into thermal energy due to resistance, and mechanical energy converted into thermal energy due to friction, we see the result of that energy conversion of the surface. We don't see into it, all right? And that's my disclaimer. Okay, so why do we do thermography, all right? And it's all about risk prevention, particularly in the electrical industry, and now it's reaching a great understanding in the mining industry and mechanical as well. So there's a number of different areas, particularly in electrical thermography, indoor and outdoor, where this risk can be averted by the use of infrared thermography. So we can also avoid events like this, and if it seems like it's a little bit dramatic, I just wanted to show you the video on the next screen from not so long ago that shows you how this translates into real life situations. No sound.
All right. I apologize about that. Let me just see here. I can fix this in 2 seconds. That's my fault.
Fire in the wire. Welcome to Four Corners. Power lines have been blamed for fires that took 161 of the 173 lives lost in Victoria's Black Saturday disaster in 2009. And tonight's story reveals new information in that regard. People also forget that in the disastrous 1983 Ash Wednesday fires in South Australia and Victoria, power lines were responsible for most of the 75 deaths. So why would anyone be surprised that a power line was again blamed for the recent Springwood fire west of Sydney that destroyed nearly 200 properties? Governments accept that the risk posed by power lines in times of high fire danger is real, but the obvious solutions come at a price. One to be measured in dollars, the other in inconvenience to the public and possible health risk. So as Australia faces another summer of serious bushfire threat, already previewed dramatically in New South Wales in mid-spring, why can't governments agree on the best way to deal with one of the biggest single fire risks? Jeff Thompson reports.
Thank you. And I must say that why I'm not saying that infrared thermography could have prevented all those fires, I'm pointing out that there are risks with electricity, and thermography is one of the great tools that can help a lot with that. And once again, if you look at government driving risk assessments, they are not driving thermography correctly when it comes to the certification of personnel and training, etc. So there are some parallels there I was trying to draw. So to give you a bit of background for those who are newly initiated to infrared thermography, it is the science of acquisition and analysis of thermal information from non-contact thermal imaging devices. The infrared thermography detects emitted radiation in the infrared range of the electromagnetic spectrum. They don't see temperature. So very important, they actually calculate it. So in the following slides, we're going to talk to you a little bit why does that matter. So here's our favourite saying in our thermography courses, of course, why it is not point and shoot. And put simply, the same object with different surfaces will emit different amounts of energy, and the camera will calculate different temperatures from that, even though that object surface is actually the same temperature. So this is my little demonstration I take everywhere, and you can see how beat up my old Anzac cup is, and I blame that on Qantas and Virgin, because that's what happens when you have a pewter mug floating around in that bag when you're flying everywhere. As you can see, it's a standard pewter mug, and we filled it with hot water, which is why we have a thermogram looking down, and that hot water is at 86 degrees. And by the way, those thermal patterns you see on the surface of the water, if we were to video that, you would see that swirling around. So that's the effects of natural convection as the hot water heats, gets to the top and then cools and then forces its way down and then forces the hotter molecules up. So we can view the effects of natural convection nicely in a cup. And here's our clear example. Same cup, same time, different temperature. Okay, in fact, it's 47% too low. All right, and so we need to take this in and understand it, that if you have objects at exactly the same temperature with different surface preparations, then the temperature that the camera reads and the thermal energy will be completely different. You need to be able to account for that to correctly make your measurements. So there's two main error sources in thermography for long wave cameras, and we won't go into long wave, short wave and near IR. And they are emissivity, which is the body's ability to emit thermal energy, and background reflected energy, which is the energy incident on the object of interest that is reflected off of the object from the background and into the camera. So we just saw the differences in emissivity, and we could see in that cup that there were patches of different thermal energies all around the cup. And that's the energy in the background reflecting into our camera. So does it really make a difference? Absolutely. And if you think about the different materials in a switchboard and those people who say thermography is only about looking for hotspots, well, here's a hotspot for you. That is clearly not a temperature difference, okay? It is purely a reflection, okay? And so having taught many people over the last 5 years, I can't tell you how many people get through these slides in our course and then come up to me and say, wow, I have reported so many false positives, and I'm also afraid of how many things I've missed because I just thought I was looking for hotspots, okay? So therefore, if you don't have knowledge and understanding, there's no value in thermography. If you think it's all about running around looking for hotspots, you are missing the forest for the trees. So think about those materials in the switchboard, think about the connections out in the outdoor thermography world when you're looking at power lines. There are emissivity differences everywhere, and if you don't understand what you're looking at, you're making some mistakes. So we'll go over a few more error sources. Emissivity differences, as I just spoke about. In materials with different surface preparations will emit different amounts of energy. Number one, understanding thermography, that is our biggest source of error. It causes the largest error in measurement. Next one down the ladder is reflected energy, as we spoke about. And for electrical thermographers, the thermal energy from the thermographer is often the biggest cause of error, okay? Not the background, because you're standing there and your head and shoulders are emitting 30 plus degrees worth of energy and reflecting off of those highly polished components in the switchboard, which makes what we saw in that other slide happen. And people go, wow, okay, we've got a problem here. We've got a connection issue or something like that. And it just simply isn't true. Another thing which is not considered. So for those who do outdoor surveys, which we do a lot of in our business, okay, in particular power distribution, and I've met a lot of people over the years who have supposedly been doing thermography on power distribution equipment in the middle of the summer's day in Australia. And besides going right into the technical details of how to set the camera, which is also necessary, they say to me, we are just driving up and down the power lines, pointing the camera and waiting for us to show us hotspots. So with solar loading, it masks a lot of the problems that exist there. And remember, people get caught up with thermography on finding things that are going to fail now, right? My favourite saying is, a blind man on a galloping horse can see something that's going to fail tomorrow with a thermography camera. What we want to find are those pre-failure conditions that are going to give you some lead time to affect those. And in electrical thermography, they can give you 12 months. That's what we're looking for. We're not looking for the things that are going to blow up tomorrow because it's too late. Convection, okay, same thing. In particular with power lines, you're looking at very small components that have a surface area that's engulfed with the air. And when there's a lot of wind blowing, that temperature difference that you're looking for will effectively be taken away by that convected energy, okay? Or the convection that's occurring with the wind, right? So once again, if you're doing outdoor thermography on a windy day, particularly if it's cool, you're missing those faults that you need to find. So why use thermography then if there's all these negatives, right? We'll run through a few of those now. So it's non-contact, it's non-destructive, it can be carried at a distance with the correct lenses, but most importantly, it's safe and it does not require shutdown. So our job is not to interrupt our client's business. Our job is to keep that running and give them some results. So where is it valuable to use? We're going to start with those outdoor components, and these are taken, one on a cloudy day on the left, and it's of a pole transform with a faulty lightning arrestor. And then the other one is taken at night time, and it's of an ABS, an air brake switch, and it has some low-level connection issues. So in both cases, they were very, well, in particular on the right, it was a very low-level fault. So it gave our client a lot of lead time. This particular ABS happened to be the main line in from the power distribution from the energy supplier. So to shut that off meant that everything down the line had to be shut off. So we were able to monitor that for them for 6 months until they could have a major outage. And it made it to that major outage instead of waking up one day and going, oh no, we've had a major outage, everything's just stopped. Okay, so that's what I keep going back to. It's the low-level faults that count, not the high-level faults. So inside and internally, not just the patterns on thermal motor bodies themselves, which can tell you a lot, but the motor body bearings, okay, the front bearing there, as you can see, has a problem, and the general in your switchboard, your distribution boards, your MCCs, you've got your connection issues on your electrical wiring. And on your outdoor substations, once again, have a look at the background there. It's a cloudy day. All right. So if I'm asked to do something during the day, I'll definitely try and say no. But if it happens to be a cloudy day like that, then you're going to get some decent thermal patterns. And as you can see in the digital image, there's air brake switches in the background. In that switch yard there are so many components that you need to understand whether they're in a state of failure mode or not. And if it's a bright sunny day, you're wasting time. And a lot of people ask about high voltage cabinets these days indoors, and say that, you know, our rules say that we can't open cabinets. So there is, of course, a solution out there, and they are IR windows. And there are a number of brands who are UL rated and or UL listed. So they're explosive, tested and rated, and they allow the thermal energy to come through a special material that's similar to the camera lens. And once again, not point and shoot, because that attenuates some of that thermal signal as it comes through those windows. So if you don't know how to account for that, and you're asked to give a measurement of what's going on inside that cabinet, then you're going to make a wrong measurement. Yes, you can qualitatively assess the components inside if you have an idea of what the emissivity of those components are inside, because you will see the emissivity differences. But if you don't know the transmissivity value and you don't understand those components, then once again, you're not going to get much value out of it.
Be a great solution for the prevention of arc flash, right?
Absolutely, yes, yep. And that is the main reason why people are putting it in. And it's, of course, the main reason why people are not opening those cabinet doors. So we're trying to limit. And if you think about the current way of limiting that is wearing the bomb suit, right? So if anyone's driven an infrared camera, it's hard enough when you've got 2 thumbs like I have, or 5 thumbs. You want to try and put double or triple gloves on, then wear a heavy suit with clothing and sweat and fog, right? And then try and drive that camera. Ridiculous. So this also helps a lot with that. And I tell you what, I try and steer away from those jobs because it's hard work, right? Not because I don't like hard work, right? I just know how difficult it is driving the camera. So the next question we want to talk about, or the topic we want to talk about, is thermography in the 21st century. And I'm really passionate about this because I work with a lot of asset managers at a pretty high level in my business. And of course, you know, everyone's talking about data today. And I always explain that we've got, you know, kind of this end of the scale where everyone wants to operate on data. And then we've got the other end of the scale where we've got the people on the ground who understand that machinery really well. And a tool like infrared thermography can bring those two together by providing meaning to the data when people are trained, okay? And it's so important to understand that, because you don't want to have failure after failure after failure to figure the data out, when you can spend a lot less money and time training a guy to give you some understanding of the data and have no failures. So that's where our inspection business has been very successful. So thermography can provide you data on the quality of installation workmanship straight after you've built something new, the quality of the components over time, the normal operating temperatures, even under varying loads. You can graph all of this stuff, right? Failure temperatures of components, failure rates of components, although I must put a bit of disclaimer in there as well that failure rate and temperature are not linear, okay? But over time, you can start to look at how components start to fail, if you like, in the PF curve kind of way. And I've observed many components that travel along quite nicely, start to heat up, and then away they go. The curve is steep, okay? And then there's those components that will slowly start to fail, okay? Continuously faulty components that should be taken out of service, or they're not suitable for those conditions. Most importantly is the success of the repair, okay? So one of our favourite things that goes wrong with infrared thermography, if we think there's a connection issue, then everyone straight away says, oh, that's a hot joint, so it must be loose. So then the guy gets a report and it says, tighten the joint. So it's already got 3 or 4 strands that are missing because someone tightened it last time. And then they go and crank it again, and all of a sudden you've got another 6 strands broken, and all of a sudden you've got half the conductor that you had in the beginning conducting the same amount of energy through, and what do you think happens? You end up with a hot joint. And next year, someone comes along. So it is such it's such a natural thing to say, oh, well, it must be loose. And in fact, it could be over-tightened already. There could be some oxidization there. There could be some incorrect components or some poor workmanship behind that. So we can't assume, right? So, but then we can go back and we can check with thermography how successful that was, that repair. And I wish I could remember, I was supposed to be able to remember this figure, but it was some ridiculous percentage of repairs aren't successful and people don't know about it, okay, because they didn't follow up on it. So if you want to take that preventative or predictive maintenance program, you know, into a proactive program, then looking at those components after the repairs is absolutely essential. And of course, at the end of the day, the last point there, because the customers have to want this, they have to drive it, you know, they're going to have to pay for it. But I've never met a customer that we've engaged long term that has never received, you know, less than 25 to 50 to 1 return on investment. So the trend is your friend, is what we always say. And if you find the right software or employ the right software or develop the right software, and you make it fit for purpose. So with thermography, trending temperatures over time and having a temperature difference, or what we call a delta T criteria, is absolutely essential when it comes to measuring like for like components and watching them over time. And, you know, in the mechanical world, this is a very well-known and tested way of looking at components in condition monitoring through vibration analysis and ultrasound. And that's the world I majority live in. And so it seemed very natural to me that electrical thermography should be doing this, but unfortunately, it doesn't seem to be a lot. So if you're an asset owner and you want to open up and see something like a dashboard, if you've got assets all over Australia or all over the state, it'd be nice to be able to open something up and see how that asset is trending. The steps to bring thermography data into asset management. Number one, you've got to train your people or use trained and experienced thermographers so that the data that you capture is actually useful, okay? So the old saying, crap in, crap out, okay? It's just like a calculator or a computer. If we don't punch the right information in, we will not get the right outcomes. And unfortunately, the camera doesn't do the work for you. It just shows you what's coming off the surface. Number two is assess your assets and develop a program properly, all right? Now, when I say properly, I mean there are some excellent guidelines out there in the condition monitoring world, ISO 13379, SAE-JA 1011. They will help you determine what assets you need to monitor, what the criticality of them is, how often you should monitor them, and even sometimes what tool you should use to monitor them. So take the time now to develop a proper program, get someone in who knows how to develop a program, and the benefits once again will pay off later. So use the software instead of PDFs. I know a lot of asset managers sing the same song at the moment. They are sick of going back and looking through folders on their computer trying to find that PDF where they knew they had a fault. They just can't quite remember what date that fault was, okay? And so, you know, my advice and my vision for thermography in the 21st century and beyond is, you know, it's almost like PDFs other than the pictures of the actual faults, which generally get stapled to a work order or something like that. They will be a thing of the past, okay? People want trends and they want to be able to open things up and see very quickly how their assets are performing, and more importantly, which ones have problems at what level. And so I really believe that this is going to be such a solution in the future.
Oh, without a doubt. I mean, it's just like viewing a photograph of something and then trying to remember where you put that photograph, you know, a month, a year, 2 years, 5 years later, as to where you can have multiple photographs to make a complete movie of exactly the transition over time. And that's really the whole thing about the 21st century, is digitizing everything to give you more information, more productivity, and more predictive capabilities to enhance products to make your assets safer. Are you froze there, Jeff? Or I think Jeff might be frozen or temporarily out of service. So we'll wait for a minute till he gets back in. It might have been my my explanation of the movie that actually made that happen. You might have got, I was just talking about still photos and now we've got a still photo of Jeff. So just bear with us for a minute or two. Yep, he's dropped out. He'll come back in. It was a good time to drop out whenever he wasn't talking and whenever I was talking. So we weren't hanging out there in the middle of nowhere. So as you can see, I mean, Jeff's breaking this down on both a basic level as well as a technical level so that we try to cater for everybody during this entire webinar. The webinar will be available for you to have after the presentation. Sandra will fill you in on that. And yeah, our hope is that we just take and bring topics like this to the public and to asset managers, to engineers, to electricians, to contractors, so that they fully understand a bit more about what we're actually doing in the industry, what capabilities are out there. Things technically are changing so fast and so rapid in the industry that it's hard to keep up with everything. You have to really pay attention to what is changing in the industry and to be able to understand what is a good thing and what's a bad thing and something you might even want to trial and see what happens. I mean, since working with Jeff now for a few months, it's just amazing the information, and I didn't realize the whole gambit of what they were using infrared thermography for. But everything from vehicles to everything, and drones, which I hope he will talk about when he gets connected back up online here. But it's that whole gambit of we initially think of, okay, thermography is talking about electrical installations, but it's not that. It's really broadened the scope out from that, and now to have that be able to be drone based is just a whole nother level. Increasing safety for one, so you take the actual humanness out of it and the potential for human incidences or accidents or even deaths, and you take that out of there, and then you use a drone to do those measurements. But one thing that I found really interesting on here as well is the fact of the reflected radiation of your own body heat. I mean, that's something I never really took into account. And it was interesting that, that reflective energy can actually be picked up by the camera. And that's how precise these cameras are, and why people, get the wrong information and say, oh yeah, I'm just measuring a hot spot. That's not really exactly what it does. So yeah, Jeff might have went out to the shop for a sausage roll or something. It seems like, I don't know. Have you got his number, Sandra? Can you give him a call and see what he's up to?
I've actually just tried to call him, so I've got his number. I'm just going to message him now.
Okay, thanks. So yeah, the interesting thing is, I don't know if Sandra's picked up any questions or not yet, but please put your questions in there. The last webinar we did was Zurich Insurance around electrical safety. We had a lot of great questions, and I'm sure that if you're thinking about a question or you're thinking about something you're not quite sure about, I can guarantee there's other people in the audience as well that actually know the same, are thinking the same thing and saying, oh, I wish I knew about this. So please pop those questions into the Q&A section or into the chat section. Sandra will catalog those, get them all ready for us at the end of the webinar, and we'll get hooked up and put Jeff on the spot, put him on the hot seat, and get him to answer those questions for us. And we'll get that going at the end. Yeah, I think the major thing is that, like I said, I mean, we're looking at adoptive technology, and even though infrared's been around for a fair while, there's development and technical advances in this technology space that just allow us to do so much more than what we currently have been able to do. But it gets back to my initial comment at the start. I mean, it's all about education, really. You only know what you know. And if you aren't aware of how to use thermography properly, like Jeff's quoted, he says, most people think, oh yeah, they just buy a $5,000-$10,000 camera and they go out there and they point it at a switchboard and that's it, and away you go, and you look for the red spot and think, oh, a red spot there, well, there's got to be a problem. There's so much more to that, and that's why I like Jeff's approach, is because Jeff has been in the industry. He's a trainer in the industry. He's a certified thermographer, and he'll take reports that your company may have the expertise to do the imaging right, but you may want to just engage his services to review those from a certified thermographer's point of view and write a report on that. So maybe your company has one of three different things. So first of all, you need the product. So you need the camera. Second of all, you need somebody trained to actually operate that camera. So, if you don't have that, Jeff and his team can come out to your site and do those inspections as well. And then the actual analysis and reporting. And that's the third section. And that's really a point to where I think is sadly missing, is that just because people are storing these images and say, yeah, we do thermography every 3 months, 6 months, a year, whatever their schedule is, and they think, yeah, okay, we've ticked that box. It's not about ticking a box.
Sorry, Kurt, I'll just quickly interrupt you. He's coming back in. He should be here any second now.
All right, great. So while Jeff gets hooked up back there again, I'll just finish my sentence. So yeah, it's that third part about the analysis and the technical reporting side of it that Jeff and his company do really well. So it's that section of the overall picture. So if you need help with any one of those three sections, just get a hold of Jeff and the team. They'd be more than glad to help you. Hey, mate, where'd you go?
Well, I've just decided from what I could hear on Sandra's phone there was that I've got a bit of an unstable connection here.
Okay, well, yeah, well, you are in northern Queensland, so we will forgive that.
And if I could just be really funny right this moment, Kurt said that you've gone, oh, have we lost him?
No, I think, well, maybe.
Oh.
Have we got you, Jeff? We got the picture of you, Jeff, but I don't know if we got voice.
That's it. We got it there now.
Oh, good, good.
Can you hear me?
We can hear you. Kurt mentioned that you've gone up for a sausage roll.
Can you hear me okay now?
Yes. And somebody in the audience asked, there's a question to say what kind of sausage roll. So I just wanted to see if you want to answer that one.
Oh, yeah. So what kind of sausage roll was it, Jeff, that you had while you had your break there?
Are we there yet?
Yeah, you kind of echo a bit, but we were going so well too.
I had a bacon and cheese sausage roll, thank you. And I tell you what, I'm going to...
Bacon and cheese. Your connection isn't real good at the moment, Jeff. You must be standing in the wrong spot, or yeah, we didn't miss a beat in the first half hour. This one we're kind of stretching, and now he's gone again.
We're trying again.
Hopefully okay, hey, that sounds all right.
Are we there? I'm really sorry. You know, I've taught about 7 classes out of this same room and don't have problems. And then the day I come on to do a webinar for you, Kurt, it seems to play up a bit.
No, it's all good. We'll just go ahead and hit back in there. We'll try to make it short and sweet so we can get into some questions. But yeah, head out from where you're going on the current slide.
Okay. So another way of making data work for you is, of course, and many people know this, they're just not doing it with thermography data, is develop the APIs from your reporting system into your CMMS, so that'll work. All your work orders can be generated automatically. Okay, so we're heading down that pathway of automation.
Whoops, we may have lost him again. Dang, hopefully you don't have to do one slide at a time.
How are we going?
Yeah, I've got you back
My
now.
goodness.
I got your sound back. I don't have photo. Maybe just turn your video off and we'll try to just capture your sound. It might not take as much bandwidth. If you're having bandwidth problems, that's a way to get around it, is just turn your video off and make sure your microphone's on. And are you there? Maybe it's everything. Our earlier video, our webinar this year was Zurich Insurance, and those guys were based out of Sydney, and it went without a hitch. So this is my first webinar that we've had a hitch. I'm sure Sandra, she's an expert at webinars. She's probably had heaps of experience with faults and failures. Not really my cup of tea. You there, Jeff? We might try, if he can, he might not be able to log in. I'm trying to think of ways we can fix this. Sandra, maybe. Oops, he's back, maybe?
Yeah. Kurt, maybe he could call in and.
Yeah, I was going to say, maybe he could call, you could give him a call, or he can call you, and we'll just put it on speaker, and he can walk through that. That might be a way.
All right, I'm trying off one other device now.
Okay, it sounds good.
Can you hear me there?
Yeah, it was just a little bit echoey, but not bad. Have you got it?
How do we have that?
Yeah, can you see the screen? If you can just go ahead and talk to the screen now, because yeah, I'll just go ahead and leave your video off just so it doesn't suck up so much bandwidth. Are you still there?
Yep, can you hear me there?
Yep, gotcha.
Okay, let's see if we can get through this without too much. My apologies. Okay. So finally enter the repairs into your software to track the successful and unsuccessful repairs. Okay. And re-image the component as we spoke about before. It's such an important step that everybody misses, and then wonders why these faults keep reoccurring. Okay. A little bit on training. So despite what a lot of people believe out there in the market, there is a distinct governance path for infrared thermography training, and it starts off at ISO, who govern the standards, and then IAS appoints the national bodies. This is very condensed, by the way. JASANS manages the accreditation bodies in Australia and New Zealand, and the AINDT, or the Australian Institute of Non-Destructive Testing, is the accreditation body for third-party certification here in Australia and New Zealand. And then we have a training body such as AIR, who supplies the training material to the accreditation body for QA, and they ensure that the material that you're being trained on does in fact meet the ISO standards. And then there's the training company that delivers the training for the training body, and they must also be approved by the accreditation body. Okay. So the AS ISO 18436-7 is the standard for condition monitoring and diagnostic machine machines, requirements for qualification and assessment of personnel, and part 7 is for thermography. So we have parts for oil analysis, vibration analysis, ultrasound, etc. Okay, so each part has its guidelines, and this is also very condensed here. But if you're a Category 1 thermography, then you are certified to do the basics. Now, the difference between certification and a certificate is simple. You go to a course and you sit the course and you pass, you have a certificate. You are trained to start to deliver thermography inspections. You are not certified, okay? So when you become certified after 400 hours of inspection time and 12 months, then you're a Category 1 thermographer who's certified in image acquisition, data collection, analysis, prevention of poor data acquisition, and reporting. And this is all to established and recognised procedures. Whereas Category 2 thermography can simply be categorised as advanced thermography. So it's obviously Cat 1 skills, plus being able to select appropriate equipment, applying thermography theory and advanced diagnosis, as well as corrective actions, etc. Once again, to established and recognised procedures. Category 3 is about, broadly, more about setting up and managing programs, including standards and evaluations, prognosis, severity assessment, and developing severity standards using established and recognised procedures such as those found in the ISO standards and as I mentioned before, SAE J11 and things, tools like that. So that's a very simplified and condensed version. However, as you can see, there is certainly a clear categorization between what you're supposed to do. By the way, you should be a Category 2 thermographer or above before you start to train or even supervise Category 1 thermographers. Thanks, Kurt. So there are my references, just so you know that I'm once again Jeff Erichsen, not making all of this up. There's certainly a lot of information out there, and unfortunately, for every piece of good information there is out there, there is some misinformation. So I guess all in all, I hope you got a very broad understanding about thermography from this, and I'd also like to just touch quickly on the different methods of acquiring this data these days. So no doubt we're all aware of the handheld cameras like in the pictures that we've seen earlier today, and more than likely we are very aware of the influx of people using drones. And then there's also fixed place automated cameras that can be set up. So I guess my caution is each discipline has its pros and cons, and unless you understand that, then unfortunately you're not going to get the right information out of it. Obviously drones is a very new and very popular discipline at the moment. I will caution that most of the drone cameras on the market today are not at the same standard as the handheld cameras of the equivalent focal plane array or number of pixels and quality. So you need to understand that, and you certainly need to know and have tested that equipment. And if you don't know how to do that, then you probably should learn. But all in all, I apologise for whatever's happened with our internet connection here. And once again, it's not a normal thing. Thanks for your patience, and Kurt, thanks for having me. And I'm looking forward to any questions, Kurt or Sandra, if you have any.
No worries at all, Jeff. Thanks very much. Now, there's a ton of information in there, and just before we get to the questions, because I've even got 7 or 8 questions rattling around in my head as well. But we just want to offer you. Jeff's graciously allowed us to have 2 of his resources. So these are 2 free documents that you can have just by attending this presentation. They're listed here. And Jeff can get into a little bit of description about what they are and what they entail, because he has actually obtained these documents from another really infamous trainer in electric technology. So I might let Jeff do that. But if you would like copies of those, just email to info@quicksafety.com and we will send those out to you. So Jeff, do you want to just go over briefly what they are?
Yeah, sure. So I have a colleague who sits on the board of the Australian Professional Thermography Association, Liam Mitchell, who has already written this detailed guide to certification and a quick guide to thermography and certification. So there was no point in me reinventing the wheel, and I'd like to thank Liam for allowing us to have these documents.
Yeah.
Once again, if we're all singing from the same hymn book and we all understand the technology correctly, then this is a great guide as to what is required for each level, and to give you a better understanding of thermography and why you need certification. And if you're the end user, if you're the end customer when it comes to the report, this will help you understand why you should look for a certified thermographer rather than just look for someone who's got a thermography camera.
Yeah, for sure. Definitely. No worries. All right. So let's jump into the questions and see what we've got. So Sandra, what do we have there?
We've actually got very active audience here. So we'll start off with some questions, and some have tried to answer, but I'll just go back to the beginning and see and direct these questions, and maybe there might be some more comments around it. But the first question at the start of the webinar was, what's the best distance from an electrical panel a person should be?
Excellent question. And that certainly depends on the focal plane array or number of pixels and your lens and the quality of the detector. So this is something that we not only teach in Category 1 infrared thermography, but we show you how to test your camera. And what we also must be very mindful here is what are the safety procedures and requirements in your facility, okay? So to answer that question, when you know how far you must be from your board at a minimum, and you know the smallest conductor that you would like to measure, then we can teach you to back calculate that so that you get the right camera and lens combination. So it's not a, you need this camera and this lens, and there's no such answer as that. It really does depend on what you're trying to do. There is a minimum specification that people recommend, and most of the thermography world understands, and that's a minimum of 320 by 240 pixels as a focal plane array. But then the lens has a dramatic effect on how close or how far away from each size conductor you have to be to accurately measure. So I know that might not seem like it helps, but certainly it will save you from going out and buying the wrong camera.
Right.
Yeah, great answer.
Great answer. Yep, I've got another question here. Which individual certification on thermography is good, ITC or ANST?
Okay, so ITC is not a certification, unfortunately. ITC is a company that produces thermography material, okay? So in the world of thermography, ISO is the governing body on the standards of thermography, and ASNT is the American Society of Non-Destructive Testing. So if you want a certification that is more recognized in America, then ASNT can definitely be sufficient. But if you want a certification that is recognized worldwide, then ISO is certainly the way to go.
Thank you. And we have another one. New South Wales Mines Department have forbidden live work, and live testing is live work. And this means you cannot open a cabinet and switchboard while live and take a photograph. There are windows into the cabinets, but these aren't that great. How can we get around this?
Put more windows in there, or larger windows. Unfortunately, if that is the way the New South Wales Department of Mines is going, and I understand why, then you can buy a window of any size. You can have them manufactured, of course, it's a cost, but you've got to back calculate what the loss of production would be if one of those components inside failed versus the cost of putting an IR window in each component. So I hope that helps.
I've got another one. So how can people advertise they're doing thermography with a qualification? Is this legal?
Yes, it's
Without a
absolutely legal.
qualification, sorry, no, without a qualification. I just saw the next line.
Oh, without a qualification. Okay, so anybody can advertise anything. It's not illegal that, you know, that they say that they're doing thermography. And this is, you know, once again, the real problem at the root of the industry is that government has not made it mandatory for someone to do thermography to have a certification. Okay, but bodies like, I strongly recommend everybody here who is in Australia or New Zealand to get in touch with the Australian Professional Thermography Association, or OSPA. Okay, they're Australia's leading thermography body. I am a committee member, so I've been involved with them since I got involved with thermography in 2013, and I must say that without the great people in that organisation, I would not be there where I am today. There is a lot of support and a lot of information and a lot of understanding. The OSPA has an MOU, or a memorandum of understanding, with the AINDT. So they work closely together to make sure that we help educate government, end users, insurers on the value of using certified thermographers. So, you know, to answer your question, it's not illegal. However, the more people that we get out there that are educated in the market, and the more people that actually have an understanding of it, and the more people who join groups like OSPA, the better it's going to be for all of us. Absolutely.
Yeah.
Thanks, Jeff.
I might just take a couple more questions, Sandra, because I will go ahead and wrap it up at 2:30, but we will come back to answer other questions. So we'll go ahead and answer maybe one or two more questions, and then we'll do the wrap up in case somebody has to go. And if you have to go, that's fine. Go ahead and go. But we will come back after the wrap up and answer the questions in its entirety.
That's
Sure.
great. Yeah. Just to finish, there's a follow-up question from a couple of questions ago about the thermography certification, and in the Q&A asked, in India, which thermography certification is acceptable?
In India, I am unsure. However, everyone that I know of starts at category 1, and that becomes acceptable. Okay, so without doubt, it is the place to start. And I can't comment on the rules and qualifications, but I have met a lot of thermographers from all over the world in the last 8 years, and category 1 is usually sufficient to get started as a thermographer.
Cool. And then I've got one more question, I guess, Kurt, and then we can wrap up.
Yeah.
We have more questions. All right. So we have Byron, who claims to be your friend from Idaho, asks, what's the best way to deal with ambient temperature or radiant heat produced by the wire coils and the temperature of connections in transformers?
What's the best way to deal with them? So ambient temperature is something that occurs naturally, and components will naturally follow. So they will heat up and cool down along with ambient temperature. So I'm not sure what you're asking to deal with that, or whether you're asking on how to deal with solar loading. But basically, if you're talking about the former, then what we're looking at is we trend our components over time against ambient temperature, and that gives us an idea of how the component is performing. Okay, so I hope that one helps.
Yeah, no, that's good. That's excellent. Sandra, did you get any responses in there about where they're from? Because I know Byron's out of the US, and I know there's a few guys in here from India
Yes.
at the moment. So welcome to everybody from India.
We do. We have some that came directly to our box. We have from Melbourne, Brisbane, Toowoomba, Mackay, Idaho, Milton. I think so far, those who have commented. Yep.
Nice, excellent.
So I'd like to say hello to a good friend of mine out there, Peter Milligan from Melbourne. He's the CEO of the Australian Institute of Non-Destructive Testing. I just saw your name on the list, Peter. Thanks for dropping in. Great to see you here as always. He's always been a great supporter of thermography and what we do.
Great. No, nice to have you here, Peter. Thanks very much for tuning in. So what we'll do is we did the same thing because there's such great topics and it's hard to cram all the questions into one. So Sandra says we've got some more questions to go. So what we'll do is I'll do the official close of the webinar, just so if people have to go, you can go. But if you can stay on, listen to these other questions, type in your questions. We've got Jeff in the hot seat. Let's keep him there for as long as we can. So officially now I'll just run through the actual closing section. So thanks very much, Jeff. Amazing presentation as always, met all my expectations and more. Great presentation, even with all the glitches. So it's just part of the 21st century we live in. And like our passion is we just want people to be informed and educated and to do things correctly, not to be misguided in a good intention, but to actually back it up with fact and give it some meat so that you make sure that you're doing thermography correctly. So thanks, Jeff, and thanks Advanced Infrared Resources Australia. If your business needs help with anything in electrical risk mitigation by using thermography, please feel free to contact Jeff. His details were in the slide earlier, and let us know as well here at Quick Safety if we can help you with anything. If your business needs a hand with further understandings of the federal and state requirements of electrical safety compliance for your assets, please get in touch with Quick Safety. We also provide independent on-site audit reviews as well to ensure that your company is fully compliant and electrically safe with state and federal regulations. So as shown today, we can also assist with all things infrared. So if it's thermography that's needed, please get in touch with us. My details are shown there, and Sandra has posted my email address and phone number in the chat window. So reach out and ensure that your life and property and reputation are protected. I want to thank each and every one of you who signed up today and attended the event. I really appreciate it. And hey, I told you I would spill the beans about our next webinar topic. So I wish we had a little drum roll section, but we don't. So electrical safety, compliance, and obligations. Now, this is going to be another cracker. So this is another thing that's widely misunderstood in the industry. You've got asset owners of every size and caliber, and they don't really know the condition of their existing electrical installation. Is it safe? Is it not? Is it compliant? They don't know if the electrical installation at their business premises is installed and maintained to the correct standards. They don't really know their obligations in relation to electrical safety, widely misunderstood within the industry, all the way from residential to rentals to commercial to industrial. It's only up until we get up into the really high end of your mining and oil and gas infrastructures that people do really understand that compliance, but everything else is pretty misunderstood. And do you maintain the appropriate records for your electrical installation and the equipment used in your business? Another vital point, especially when it comes to insurance claims. And could you prove that your staff have been trained to work safely with electricity? So our next presenter on the 1st of July is a super qualified expert in this area. And I see that he actually is, yeah, he's still with us at the moment. So I see he is in the audience. So I won't release any names because we're going to keep it suspenseful, but he's got a ton of experience. It'll be a fantastic webinar. So look out for it. Drop me an email if you want a direct link to the webinar and we'll hook you up. And we'll cover all this the next time on Quick Safety's webinars that help assist you to stay safe, stay compliant, and stay out of court. So thanks everybody once again. And all right, so let's go back to the questions and finish this off. Back to you, Sandra.
Thank you. We've got the next question is a little bit technical. So I'm just reposting it in the chat window for everybody, just in case I'm mispronouncing anything. Are there Australian standards around thermography? Australian standards adopted the ISO standards for thermography some years ago, with two of the major thermography standards being AS/ISO 184367-7 training and 18434 delivery. So I hope I did the pronunciation okay. And and I've reposted the question in the chat window.
Yep, and that is absolutely correct. Yep. Australian standards have adopted the ISO standards for thermography, so they are the Australian standards.
Okay, cool. Next question. If I do a course and get a certificate, am I certified?
I can definitely answer that. Okay, so as I said earlier, if you do a course and get a certificate, that means you are trained to begin to deliver infrared thermography surveys. It does not mean you are certified. It means that you are trained only, okay? To become certified as a Category 1 thermographer under the ISO standards, you must carry out 400 hours of practical thermography, and that must be logged and signed off by your supervisor over a 12-month period. You must then sit another exam, which is delivered by the AINDT, and then you must send in 2 reports for review by the AINDT to ensure that your reporting is up to standards. So I hope that helps.
So I just had a question when you mentioned that in the topic, Jeff. So what happens? I mean, is it like, what happens if you get to like 350 hours in a year and you don't get, 12 months elapses and you're 50 hours short? Then what happens then? Do you know?
Yes, sorry. It doesn't have to be within a year. It just means it's a minimum of 12 months. Yeah. So you can accumulate that generally over some, I think, I'm pretty sure it's a 5-year period. And when you want to recertify, you've got to accumulate another 400 hours over another 5 years from memory.
Gotcha.
Yeah.
Gotcha.
Great. So the next question is, if I'm only doing basic inspections, do I really need training?
And yeah, the answer is absolutely yes. So everybody is only doing basic inspections, okay? So when I go out to a site, doesn't matter which site, I've just recently done a survey at an engineering company's building, right? I am doing Category 1 thermography done well, right? And the last inspection I did, I actually had 2 electricians who said exactly the same thing because they were doing surveys, right? And I was very particular about wanting to know if they actually wanted to learn first, and then they said they did. And then I was very happy to show them the faults that I'd found. Now, these guys have been there, quite often delivering repairs and using their low-end infrared camera and never knew any of these faults existed. They've been doing that for 7 years, okay? So any inspection is an important inspection, and you don't know, unfortunately, what you don't know. So all I can say is that once you get trained, you will be able to see the trees in the forest, and you will get a great understanding of what it was that you were missing before you thought you were just doing the basic inspections. So it's an imperative yes, and we've proved it a number of times. Okay.
Thanks, Jeff. And there is a follow-up question with what you just responded. Like with just doing basic inspections, do I really need a good camera? Okay.
So the golden rule is the poorer the quality of the camera, the better the thermographer you have to be able to get the information from it. Okay. So I just want you to, for those of you, hopefully, if the people that are asking the question were around when digital cameras first came out. Okay. So here's a direct correlation that you can make. When digital cameras first came out, they were under a megapixel. Okay. And I don't know if you can remember, but the images were often very grainy in comparison to 35mm film. Now, a high-end infrared camera that is worth anywhere between $20,000 and $40,000, depending on what brand you buy, has less than a third of a megapixel worth of pixels in it. Okay, and so when you buy a cheap camera, they usually range from about, so that's 307,000 pixels. The minimum standard is about 76,800 pixels. And when you're looking at these cheap cameras, C3 is 640 pixels, right? some of those pixels will go up to, you know, maybe 10,000 pixels. All right. Now, what happens, the difference between infrared thermography and digital photography is that each pixel is isolated thermally because it can't afford to conduct information between them. And so a lot of the smaller wiring, depending on the distance, once again, the lens configuration, falls in the gaps between those pixels. And the measurements that you gain from a low-end camera are wildly inaccurate. And once again, we prove this every week we teach a course. So I'm not trying to, you know, put anything down. I'm just giving you the science behind it. At the end of the day, you need if you're a good thermographer, you can probably make sense of what's going on with a crap camera. But if you are an untrained thermographer and you've got a crap camera, what you're going to miss, you will never know. I hope that helps.
Thanks, Jeff. We have another question. We don't have a budget for a reliability-centered maintenance program, an RCM. Yep. So I only want to see the really bad faults so I can save my business money on preventing breakdowns. Can't we just do a quick look around for these type of faults?
Yeah, that's a really common question out there in the world. Okay, so I guess I'd like to think of your wheel bearings on your car. All right, and if you went to a mechanic who was supposed to check those wheel bearings every, say, 5,000 kilometres, right? And would you ever say to him, yeah, listen, mate, this service, I'm not sure I can afford the time to check those wheel bearings. I know there's a noise in there somewhere, but maybe you can just give it a quick spin and listen to those wheel bearings, and then you can also guarantee me that wheel's not going to fall off between now and the next service. That's effectively what you're asking someone in reliability when you ask them if we can just come in and take a quick look around. You're never going to be able to understand a component by taking a quick snapshot unless there's something horribly wrong already, okay? And so I use the car analogy a lot because when people don't own the machine, even though as much as they have some great intentions, they often treat the machine with a lot less respect than they do with their own car, and particularly what they would put their family in. So my guys and my team and I, we treat our customers' equipment as if it was our family car, okay? So we want that regular servicing. We don't want the wheels to fall off. If there's a noise, we want to know what caused that noise, because there's no way in the world I'm going to send my family out in something that I think may break or cause an accident. So I hope that helps.
Thanks, Jeff. I know Kurt's got a couple of questions, but before we go to Kurt's question, just a couple of comments. Sarang, he has this great presentation and very informative session, and he's also an electrical safety auditor in India, so he's looking forward to joining in the next webinar on electrical safety.
Yeah, thanks, Sarang.
Thank you.
Thanks very much.
Thank you, Sarang. Much appreciated.
And then we have a comment from Stuart Grant referring to the previous question about the camera. I just wanted to share with all of you. And if you think 40K is dear, the camera he used to was 160K when it first came out, and it was only one of two models newer than the ones you need for liquid nitrogen into.
Wow. Yes. So you've been around for a while, mate. Great job, and thank you for that, because it is a perfect understanding of how far the technology's come and how far it's come down in cost as well. And I hazard a guess that it was probably, you know, a 320 by 240 with a cool focal plane array, and so that was a 76,800 pixels, but with a mid-wave camera. So, you know, it's come a long way, and it's certainly come down in price a lot. So thank you for that. That's excellent.
So now over to you, Kurt. If you want, you said you had a couple of questions. I've just
now Wayne Gibbons. I see that he's actually gone. He's a very busy man. He's a a contractor that uses Quick Safety on our compliance apps, and he had asked up here before. I'm trying to find again here now. He had asked, his question was, so how long can people advertise they are doing thermography without a qualification, and is this legal?
Yeah, I think we spoke about that a little bit earlier, Kurt. And it was basically, you know, it's not illegal to advertise that you're doing thermography without a qualification because the government hasn't mandated it. It just means that someone's advertising something they really know nothing about, unfortunately.
Yeah, no, that's all right. That's fine. I might have been busily engaged in something else, but I see that we've got the guys from Ashburn and Francis up in Toowoomba online as well. So thanks very much for Brian Kinney and the crew in there for tuning in and for getting their CPD points up. So thanks very much, guys, from Ashburn and Francis. They're a major encouragement and supporter of Quick Safety. So thanks very much, Brian, and the guys up there and girls. Yeah, I think that's the initial questions that we had. Sandra, did we run through those as well?
Not all the questions have been covered, but we've just got a new one that's just come in, actually two new one now.
Okay.
So AJ has asked, does an out of focus camera leads to incorrect temperature measurements and low quality reports at distance from electrical equipments also affects temperature measurements? I hope I'm pronouncing them right. I've just
No, and that's
Okay.
that you are. Yes, absolutely. And that's another great question. So an out of focus image absolutely leads to incorrect temperature measurements and also temperature differences, okay? And distance from electrical equipment also affects temperature measurements, because if you're too far away, once again, part of that component that you're trying to measure falls in between the gaps, if you like, between the pixels at that distance, and an accurate measurement is not possible. So 100% right there. The next question, please.
Yeah, the next one from Glenn Steiner. What is the cost of the Cert 1 course, please?
Okay, so Cert 1 courses, depending on which company you train with, range anywhere from $2,500 to $3,200, okay? And I can only say that you should go to the AINDT website, make sure that you are being trained by someone who is a qualified training body from the AINDT, and then you know that you're going to be trained to ISO standards, but also you're going to be able to follow up and gain a certification. When you gain that certification, by the way, with the AINDT, that certification is pretty much valid all over the world, because the AINDT have an MOU with the BINDT, the British Institute of Non-Destructive Testing, which are one of the largest non-destructive testing groups in the world. So it really does set you apart. Hope that helps.
So do you offer that training, Jeff?
I absolutely do. Yep. I'm trying to remain non-biased here, Kev.
Oh, mate, you should plug yourself, mate. Plug yourself. Plug. No, that's fine. I mean, that's exactly why. I mean, as everybody can attest that's on the webinar here, I mean, we've heard from a really passionate industry leader, qualifications everywhere. Yeah, I would thoroughly suggest that, you know, if you did want training as a Cert 1, is to go through there, because there's nothing like going through training and you think you're doing the right thing, and then you get into your training and you get some cert that really has no clout, and you can't, like Jeff said, you can't take it from country to country. I mean, the amount of electricians that I talk to and contractors that have migrated here from England is astounding. It seems like we've got, you know, a fifth of our electrical people in the industry are coming out of England, and they're really focused on compliance and safety, which is good to see. But if your certification goes across country realms, how much better is that? You know?
Absolutely, and that's why my team and I, when people come on board with me, yes, they get their training, but then it's a clear mandate from our company that they must get an AINDT certification. So it's very important in my eyes that I not only for myself, but for all of the individuals that I have contact with, and certainly those who work for our inspection company.
Yeah, for sure. So, I mean, from a layman's point of view, and this is directly me speaking, when we talk about the focus of the camera, like the second to last question, I understand that, but so what is the actual trick? Do the cameras not have a distance measuring device, or is that not a thing in infrared?
No, some cameras have a distance measuring device, but you still need to be able to determine how far away from any size object you need to be before you can measure it. Okay, so it's mathematically calculable. It's a phenomenon called instantaneous measurement field of view for those who like the technical side of things. And so once again, in round figures, and I don't like using this quote because it gives people a false pretense of the calculation that you can make. But it's well known that you need at least 3 pixels by 3 pixels, so 9 pixels square, or 5 pixels by 5 pixels, right, square, on your object of interest to take an accurate measurement. Now, the reason why I'm reluctant to sort of use that as a calculation is where I see that going wrong is in the solar inspection world. They use that exact calculation, if you like, to determine how high to fly over the pedals with your drone. Now, what they haven't taken into consideration is the quality of the lens and the focal plane array and the pixels contained within those focal plane array. So having done a bit of testing on those types of cameras, I've found them lacking a little. So we're very careful when we teach category 1 thermography to make sure people understand that we should be physically testing this distance to spot size, if you like, ratio, which is what it's known as in other parts. Okay, so it's an understanding, and forget, Kurt, I'm not wearing my glasses today, so you can imagine that if I'm trying to get a great image and trying to look at a camera, well, then I'm trying to focus and understand what my distance would be to get focus, and if I don't have my glasses on, well, that may not be that great either, So I always sort of talk about the camera, lens, person combination, or I might be very shaky, and so that also affects measurement capability in a certain way. So when you get your specifications from your camera out of the box, you've got to think that obviously this was done under perfect conditions with a black body that the camera reads very, very well. So we can't just rely on a specification. Hope that makes a bit of sense.
Sure. Yeah, totally, for sure. No, that's great. That's fantastic. There's so much, knowing just a little bit about it. And then after watching your presentation now, I realized that I probably didn't know about as much as I thought I did originally, even though it was very little. But yeah, it's just really opened my eyes up to a lot of things. And I appreciate your involvement with us today and your continuing working with Quick Safety. I mean, I think, you do great things, and it's great working with professional companies that are very knowledgeable and have the same heart and mindset of that safety in the electrical industry that we're all really passionate about. So thanks very much on that. Was there one certain last shot over the bow, one final comment that you want to leave with everybody?
Yeah, sure. I mean, first of all, thank you, and likewise, it's I've really enjoyed the time we have known each other because you are so passionate, and I am obviously a passionate person. We always talk about this in OSPA that if enough people are saying the right thing, then eventually people in industry will listen. So that's what we're trying to do. We're trying to say the right things and all say the same things because it really does matter. But I guess as a finality, I understand that equipment's expensive, and so is training, and then gaining experience is training. But I always can put my hand on my heart and say I've walked this walk. So I'm a small businessman. I went out and spent My first camera lens combination was $55,000. Then I did a course that cost me $2,500 plus accommodation plus, you know, and then I went and joined OSPA and I sat in on my first conference immediately, the day after I finished my infrared thermography course. So I've done that investment. I was a tradesman who thought I knew about taking temperatures and I thought I knew about heat, but I quickly found that I didn't. So I'm no different to anybody out there. And I can only say that it is, when you put the time, the money and the effort in, the reward that you're going to get from this discipline is absolutely outstanding. So it's just one of those things that if you have an interest, make the leap of faith and enjoy it. Thank you.
Yeah, no worries. That's a great ending, and love your passion, love your commitment to the industry. Even with all the glitches and things today, so we went down the glitch thing, so it's all good. Even me, I didn't turn the sound on, so that's my in the practice webinars, I got the sound right and everything, but today I just forgot it. But anyway, that's okay. So thanks everybody for attending, and thanks for everybody staying on. That's great to see that people staying to the final mark, final bell, and that we just hope and are encouraged that you have got some great information. You've got Jeff's details there. You've got my details there. You've got the actual the webinar here for the 1st of July. So mark that in your calendars, July 1 at 1:30 Australian Eastern Standard Time. So we'll come back, we'll do this again, and we'll all enjoy and share. In the meantime, be safe and stay compliant. And most of all, stay out of court, stay out of trouble, and have a wonderful 3-day weekend. Thanks, everybody.
Thank you very much. Appreciate it.